Now we are going to learn a new term called gravitational potential at a point. Here, the term gravitational potential is represented by the letter V. What is gravitational potential? Gravitational potential due to the mass m1 that could be measured at a point P. Are you clear? So here, first we have to find out the formula. First we have to derive the formula for V. How to derive? For that, this formula is required. What is U? U is nothing but gravitational potential energy. So in this system, mass m1 and m2, this much amount of gravitational potential energy is stored up. But we are going to find out, we are going to learn a new term called gravitational potential at a point. How to calculate V? For that, the formula is V is equal to this U, that gravitational potential energy is stored up in the system, that is to be divided by m2, because at P only we are going to find out the V. At a distance r from m1 at P, we are going to find out the value of V. Are you clear? So V must be written properly. V is different from U. U is called gravitational potential energy. V is called gravitational potential energy that should be measured at a point P due to the mass m1. Are you clear? So at point P, one mass is placed. That mass is m2. That mass must be written in the denominator. So gravitational potential energy, if it is divided by m2, only then we are able to calculate the gravitational potential at a point P can be calculated. Substitute now, instead of U, substitute G m1 m2 divided by R whole divided by m2 can be substituted. But here we have to place the unit mass. m2 must be taken as unit mass. Let us imagine unit mass means it should be equal to 1 kg. So in both the two expressions, we can substitute 1 kg. G m1 instead of m2 I am substituting 1 divided by R. Here also you substitute 1 kg. So both can be cancelled. So finally we are able to get the expression for V. So what is the expression now? G m1 divided by R can be written. Are you clear? So here in bracket you have to write R. Why R is written? Because the gravitational potential at point P is calculated. That point P is located R distance from m1. So this is the formula. With the help of this we are able to calculate the gravitational potential. Understand? Gravitational potential that should be calculated only at a particular point due to this mass m1. Are you clear? So here we will work out on problem. Only then you are able to understand. Let us imagine in the space one 3 kg mass is there. Imagine, is it clear? Here point P is there. So at point P, I would like to calculate the value of V. Are you clear? Value of V. So at a distance, let us imagine here the distance is 1 meter. How to calculate the gravitational potential at a point P? Here we have to place 1 kg. Are you clear? 1 kg mass must be placed. Are you clear? So V is equal to gravitational potential at a point P due to this 3 kg mass is equal to, what is the formula? G m divided by R is the formula. Here we know very well that G value 6.6 into 10 to the power of minus 11 into that mass value. This mass must be substituted. 3 whole divided by 1 meter must be substituted. Are you clear? So if you multiply, you will get the answer. Are you clear? 8 and then 9. Is it clear? 1998 into 10 to the power of minus 11. If the decimal point is placed, you will get 19.8 into 10 to the power of minus 11 you will be getting. This is the value of gravitational potential at a point P. This one must be represented by the unit called joule per kg. This is the unit of V. This is the unit of V. Are you clear? So here V is different from U. To calculate V, what is required? U is required. U is called gravitational potential energy which is stored up in the system. Within this 2 mass, some amount of energy is stored up, that is U. But V is called as gravitational potential. Now we will see the definition. What is the definition of gravitational potential at a point. Look at that. Again I will draw this same mass. Are you clear? The same mass m1 is written. Here imagine, is it clear? Nothing is there. Are you clear? Some distance is there. Here this m2 that must be placed at infinity. That must be placed at, is it clear, infinity here. Now we are going to do some work done. Are you clear? We are going to do some work done. So here this m2 mass, this unit mass, it could be taken as unit mass. This m2 mass that is to be brought from infinity to which distance? R distance. This m2 mass, unit mass, that must be brought from m2, the mass must be brought from infinity distance to which distance? R distance. For that we have to do some work done. That work done is called gravitational potential at a point P. Are you clear? Look at that. Again I will define the term gravitational potential at a point. Gravitational potential at a point P is defined as, how to define? The amount of work done which is required to move a unit mass from infinity to a particular distance. So clear, that particular distance means that point P is located r distance from the mass m1. Are you clear? For that we need some work done. We have to do some work done. That work done is called gravitational potential at a point P. So this is the definition, this is the expression. Here I have done one problem also. Are you clear? So to calculate the gravitational potential, which mass is required? This mass is required. Understood? The distance is also required. With the help of this we are able to calculate V. That V is a scalar. That V is a scalar. Don't forget that a gravitational potential is a scalar. Understood? Thank you.